Good morning, dear students. I am welcoming you all to the second year mechanical department. We are having in 2-1 the core basic subjects like strength of materials, engineering thermodynamics, material science and other subjects. So here we are going to discuss about strength of materials, their objectives, outcomes and what are the basic terminologies that are used in the strength of materials. And in this lecture we are going to discuss about the first unit of the strength of materials. Now strength of materials is a subject, it is a course you are having in second year second semester. Subject code is GR18A2039. Myself Sivanagaraja, working as associate professor in mechanical engineering department, GRIET, Hyderabad. Now it is the lecture 1 is mainly deals with course objectives, course outcomes and introduction to the strength of materials, and first unit, some part of the first unit we are going to discuss. So course objectives. Course objectives are the goals or the end results what we are going to expect. That means while designing the syllabus of any subject, so we are going to have some objectives or the goals what we are going to impart to the students. So that means we are going to divide the syllabus into 5 units, and each topic in the syllabus is going to have its own importance and it is useful to the mechanical engineering students and the community. Now the objectives are to provide the basic concepts and the principles of strength of materials. So here it is not an advanced subject, it is just extension to the engineering mechanics what you have studied in your first year. To study the stress, strain and elastic constants of different materials. That means the concept of stress, strain and elastic constants we are going to see for a different materials. That means each material is going to have its own mechanical properties. So that means in the strength of materials we mainly deals with the mechanical properties of the materials. If you are going to apply a force or a load on any component or a material, what the changes that are going to occur and what is going to happen to that component we are going to study. That is mainly related with the stresses, strains and the constants related with the materials. Third one, to gain knowledge about shear stress, bending moment of different beams subjected to various loads. So that means if you go through the second unit of the subject, we are going to see the beams. What are the types of beams and what are the types of loads you are going to apply, and after the application of the load what is going to happen to the beam, at what each point what is the shear stress and what is the bending moment for a different beams and different loads we are going to study. That is the objective. That means we are studying stress strains and shear stress and bending moment for a beams. Like fourth one, to obtain knowledge about the effect of torsion on the shafts. So that means stress strain, it is the basic terminology in the first unit, and types of beams and application of shear application of the loads, different types of loads. And we are going to do the shear stress and bending moment diagrams in the second unit. That is the objective. And the third, there is nothing but fourth one is the effect of torsion. So what is torsion, and what if you are going to apply the twisting or the turning moment to the shaft, what is going to happen and what is the effect you are going to get. And the fifth one is to understand the flexural and shear stress concepts for different materials and shapes of the structures. So that means you are applying a load on a beam. So beam section is going to have different section. The section may be I section and T section. That means each layer of the section you are going to have flexural stress is nothing but the bending stress, and the shear stress also. That means we are going to analyze the shear stress and bending stresses for a different sections of the structures. So that is the course objectives. That means I have framed my syllabus of the strength of materials in such a manner that I am going to give all these basic concepts. That is the objectives. Now what is the outcomes? That means as a student, after completion of the syllabus, what you are going to gain or what is the knowledge you are going to gain is nothing but the course of outcomes. At the end of the course, the student shall able to understand the theory of elasticity, including stress displacement, Hooke's law relationships, analyze the shear stress and bending moment diagrams with various types of loads, analyze the shear stress, that is the thing, and the next one is the calculate the slope and deflection of the beam subject to the transfer load, that is nothing but also beams. Not only shear stress and bending moment, but also we are going to see slope and deflection. You are going to calculate that one. Analyze various situations involving structural member subject to the combined stresses and solve the torsion problems in the bars. Next one, evaluate the bending and shear stresses in the beams. What we have seen that one. So that is the course outcomes and the objectives of the subjective. Now we are going to see the introduction of the subject. So what is the introduction of the subject? So in the introduction to the strength of materials, so we are going to see about that means strength of materials is also called the mechanics of solids. That means it is related with only solids. That means the mechanics of other materials like fluids and gases are going to be studied in the fluid mechanics. But in our strength of materials, we are going to deal with only the solid materials. That's why this subject is also called the mechanics of the solids. Mechanics is nothing but if you are going to apply a force or a load on a member, that is nothing but a solid member, what is going to happen and what is the resistance that is offered by that solid materials, you are going to see that. Next one, in the design of structures and machines, the application of principles of strength of materials is necessary. Suppose if you want to design any structure, any machine, it is the combination of various parts. So and finally, if you are going to apply a load at one component, it is going to be transmitted or transferred to the other component. That means it is going to affect all the remaining components. The application of the principles of strength of materials is necessary if satisfactory materials are to be utilized and adequate proportions obtained to resist the functional forces. That means without deformation, you need to design in such a way that there should not be any permanent deformation that is going to take place in the structural member. If the permanent deformation is going to take place, then it is no use at all. That machine, that is the thing. Forces are produced by, how the forces are produced by the action of, that means you come across all these terms in the fluid engineering mechanics. Gravity by acceleration and the impacts of moving parts by gases and fluids under pressure by the transmission of the mechanical power, etc. In order to analyze the stresses and the deflection of body, the magnitude and directions of point of applications of the forces acting on the body must be known. Last one, information given in mechanics section provide the basis for evaluating the force systems. You come across different types of force systems. Next, it is the unit 1. That means whatever we have we are going to study here in the unit 1, these are the mainly it is related with the terminology related with the simple stresses and the strains. In detail about this one, this is the concept of stresses and strains. So stresses and strains may be in linear, lateral, shear stress, thermal and volumetric strain may be takes place. Next one, Hooke's law, Poisson's ratio. So we are going to come across all these terms. Modulus of elasticity, modulus of rigidity, bulk modulus. Next important one is the stress strain diagram for the ductile and brittle materials. And in the stress strain diagrams, you should know what the proof stress, what the true stress and strain, various strengths of materials. That is yield strength, ultimate tensile strength, factor of safety, FOS, strain energy. Gradually, sudden and impact loads. What is the strain energy there? And the concept of stress state, relationship between the elastic constants, axial forces, stresses and strains in determinate and indeterminate bars and composite bars. Bars under axial loads and the self weight. That means it is the objective 2 is going to be fulfilled here. And after completion of the syllabus, you came to know what is the basic terminologies and what is the basic applications related with the strength of materials. Now after this introduction and the terminology related with that one, we are going to move to the very important topic, that is nothing but the mechanical properties of the materials. That means in strength of materials, so we are going to see the mechanical properties of the materials. So that means the solids are going to subjected to, that means a mechanical component is a solid is going to subjected to various types of loads, and what will be the effect of the load or a force on various components, and which property is going to influenced by the application of the load, and various applications are going to be, suppose if you want to draw into wires, or if you want to make some metal into the sheets, so what are the effects, and some materials may withstand the scratches on the surfaces, there is a surface hardness, so that is going to be studied. The mainly strength of material focuses on the application of the various types of loads and the forces and their effect on the various components. So for that we are going to see the mechanical properties. So similarly we are in metallurgy, we are going to see the metallurgical properties, that means what will be the grain structure and what is the this one. So similarly if it is related with another chemical properties, but we are not going to deal anything related with the metallurgical properties, chemical properties and another properties. We are going to see only the mechanical properties. The first one is that is nothing but strength. Strength is the ability of a material to resist the externally applied load without failure. So that means if you are going to apply a load, indirectly I have told it is the force is going to be applied, then there is a deformation. Deformation is nothing but the change in the dimensions of the component is going to take place. If you keep on increasing the load, then what is going to happen? There is a chance of failure of the component is going to take, it may break down into pieces. So that is that ability to withstand the externally applied load is nothing but the strength. Now you are going to see the this one. So it is nothing but the stress strain diagrams. That means if you are increasing the load like this, it is a linear direction, and up to this it is in the elastic limit. After that it is going to the plastic zone. After that there is a chance of having the failure. So that is the strength. And the next property is the brittleness, the tendency of a material to fracture or fail upon the application of a relatively small amount of force, there is nothing but impact or a shock is nothing but the brittle. Example, cast iron, glass and ceramic. If you drop the glass, it is going to fail completely. That property, a ceramic is going to fail completely. That is nothing but the brittle property. So you are going to see that one. So a brittle material is going to be forced in between two plates. If you apply the load, then there is a complete failure of the this is going to take place. That is nothing but the brittleness of the material. Next one is the malleability. Malleability is the property by which a metal can be rolled into thin sheets. Suppose if you want to make any thin sheets like this, so the solid or a material must have the property of malleability. The materials are steel, so steel plates or sheets are going to be formed. That is another the property. And the next one is the ductility. Ductility is the property by which a metal can be drawn into thin wires. It is determined by percentage elongation and percentage reduction in the area of the material. So example, steel, copper and aluminum may be drawn into the wires. So that means suppose it is a brittle material, you can't draw them into the wires or you can't make them into plates. So if you want to make them into sheets, the material must have the malleability property, and if you want to make the material into a thin wires, it should have a property of ductility. Now you can see that it is going to be drawn, so and it is going to be wound. That is the ductility property, the property by which a metal can be drawn into thin wires is nothing but the ductility. The next one is the hardness. Hardness is the ability of a material to resist scratches and indentation, also resist permanent change of the shape caused by the external force. Example, diamond, cast iron is going to have that is nothing but it is nothing but surface hardness. So if you are you can come across so many applications like that. A load is going to be put on a plate for some time, or it may be some load is going to come from one place to the other place on the surface. So there should not form any scratches. If it is continuously forming the scratches, means the shape is going to be changed. The intended purpose of the component is not going to be solved. So that is nothing but the hardness. Hardness is the ability of the material